Hello everyone, I am Shailaja and this is a presentation on IR proximity sensor concept and working. These are the contents that we are going to study throughout this presentation. First of all, let us see what is proximity sensor. A proximity sensor is a sensor able to detect the presence of nearby objects without any physical contact. When anything comes in the range of proximity sensor, it flashes out infrared beam and monitors reflections. When sensor senses reflections, it confirms that there is an object nearby. It converts the information on the movement or presence of an object into an electrical signal. The object being sensed is often referred as proximity sensors target. There are different types of proximity sensors like inductive, capacitive, magnetic, photoelectric and IR sensor. We are going to see the IR sensor in detail. IR proximity sensor. An infrared sensor, it is an electronic device that emits in order to sense some aspects of the surrounding. An infrared sensor measures the IR light that is transmitted in the environment to find objects by an IR LED. This type of sensor is very popular in navigation for object avoidance, distance measurement and line following applications. These type of sensors measures only infrared radiations. Usually in the infrared spectrum, all the objects radiates some form of the thermal radiations. This type of radiations are invisible to our eyes that can be detected by an infrared sensor. This sensor is very sensitive to IR lights and sunlights. And this is the main reason that an IR sensor is used with great precision in spaces with low light. Infrared radiation. It is the portion of electromagnetic spectrum having wavelengths longer than the visible light wavelengths but smaller than microwaves. That is the region roughly from 0.75 micrometer to 1000 micrometer is the infrared region. Infrared waves are invisible to human eyes. The wavelength region of 0.75 micrometer to 3 micrometer is called near infrared. The region from 3 micrometer to 6 micrometer is called mid infrared and the region higher than 6 micrometer is called far infrared. This is what the IR sensor is. It consists of one transmitter and one receiver. The IR LED will act as a transmitter and the photodiode it will act as a receiver. An IR photodiode which is sensitive to IR light of the same wavelength as that emitted by the IR LED. The receiver will need an enclosure or shield to block direct or reflected infrared light from other emitters. This is the circuit diagram of the IR proximity sensor. It consists of different components. The resistors R1, R2 and R3. It consists of an IR transmitter and receiver pair, variable resistors VR1 and VR2 that is potentiometers, LED that is light emitting diode, and here is the LM358 IC which we are going to use as a comparator. This is an inverting input and this is a non-inverting input, and according to these inputs it will give an output as an analog voltage. This circuit comprises of the following components, that is just now we have seen LM358 IC, resistors, variable resistors and LED. This is what the LM358 IC is. There are two inputs V1 and V2, and when V1 is greater than V2 it will give output as a VCC that is plus 5 volt, and when V1 is less than V2 it will give the output as a 0 volt. This is the working principle of the IR sensor. The IR receiver when does not receive any signal, the potential at inverting input goes higher than that non-inverting input of the comparator IC. Thus the output of comparator goes low but the LED does not glow. When the IR receiver module receives signal to the potential at the inverting input goes low. Thus the output of the comparator goes high and the LED starts glowing. The resistors R1, R2 and R3 are used to ensure that minimum 10 mA current passes through the IR LED devices like photodiode and normal LED respectively. The resistor VR2 is used to adjust the output terminal, and the resistor VR1 is used to set the sensitivity of the circuit. This is how the target detection is done by the IR sensor. This is an IR LED which will work as a transmitter, and this is the photodiode which will work as a receiver, and this is the target object. In the infrared sensor, a narrowband infrared beam is transmitted from the LED. When the beam strikes an object, it is reflected back towards the sensor and into a focusing lens. A focusing lens directs the reflected beam onto the PST, that is photodiode. The incident angle of reflected beam is determined by the distance from the sensor to the reflecting object. Furthermore, as the reflecting object moves further and further away, the change in angle at which the reflected beam decreases, that is sensitivity decreases. The location at which the reflected beam strikes the photodiode is determined by the distance between the transmitter and the reflecting object. This infrared sensor can be used to sense objects from 10 cm to 80 cm away. The most important thing is the object detection range. There are different sensors that is used for a short range detection, that is from 10 cm to 80 cm, and extra long range detection, that is from 100 cm to 500 cm. These are the types of sensors, that is digital and analog. In digital sensor, output is digital, that is high or low, and in analog sensor, detection depends on the intensity of light received. The sensor with a binary output are only good for detecting the proximity of an obstacle and not the range. The other IR sensor which are ranging sensor output the actual distance of an obstacle from the sensor. This output can either be analog or digital byte. These are the schematic of the digital IR receiver and digital IR transmitter. The digital and analog IR transmitter have the same schematic, but in receiver there is one change, that is in digital receiver we are using the op-amp 358 or a comparator, and in analog receiver we are using the photodiode. Then applications of the IR sensor. IR sensors are used in various sensor-based projects and also in various electronic devices which measures the temperature. First one is the radiation thermometer. IR sensors are used in a radiation thermometer to measure the temperature depend upon the temperature and the material of the object, and these thermometers have some of the following features, that is measurement without direct contact with the object, faster response, easy pattern measurement. Then next is the moisture analyzer. Moisture analyzer uses wavelengths which are absorbed by the moisture in the IR region. The next is the robotics. In robotics, to detect the obstacle, we can use the IR proximity sensors. Security. Movement or motion detection, fire alarms or smoke alarms uses IR sensor. Games and toys, that is remote control models, also uses the IR sensor. These are the advantages by using the IR sensor. It has a low price, then there is a broad variety of applications, it is easily available, it can be easily interfaced with any microcontroller. Then higher security, that is beam directionality helps ensure that data isn't detected and leaked to nearby devices as it's transmitted. High noise immunity, that is, it is not as susceptible to signal interference from other devices. Low power requirements, it requires the less power as compared to the other sensors. These are some disadvantages. That is, it gives a bad performance in sunlight. It is affected by the external atmosphere. That is, these are affected by external atmospherics and nature of the object or the surface. The range is usually very less, and it can be easily affected by dust particles on the sensor, rain, or dark objects. Then short range. Performance drops off with longer distances. Then line of sight. Transmitters and receivers must be almost directly aligned. Then the conclusion is that proximity sensors has the advantage that you don't need to bring your object or a target in contact with your sensor, so your object is saving from getting disturbed. If you do not care about incredibly accurate ranging, you can go for IR sensor, but it will not be used outside in the sun. This is all about the IR proximity sensor. Thank you so much for watching this video.